Okay, thank you, Devs. By way of introduction, my name is Dr. Leslie Matswane. With me this evening is Jim Czuprynski. Jim, we are honored to have you this evening. Jim is an Oracle ACE director who will be presenting the topic Create Uber Fast Maps with 23 AI, vector tiles, and H3 indexing. Jim is a highly respected in the global Oracle community for his deep technical expertise and his ability to make complex concepts practical and also engaging. Jim, we are very excited to learn from you tonight, and we are hoping to explore how these innovations can transform the way we work with geospatial data in Oracle. Without any further ado, sir, I would like to hand over the floor to yourself. Thank you.
Thank you. Thank you, Doctor. Well, I'm excited to be here. I love talking to people everywhere. Let me just go ahead and share my screen. This is going to be a bit interesting because there we go. Usually I have this one is a little trickier to present because I've got demos and a few other things. But my topic today is, as Doctor said, creating faster maps with these two new features in 23 AI, vector tiles and H3 indexing. So let's dive in. I love talking about anything related to maps. A little more about myself. As mentioned in the intro, and I'm going to cut my video feed for right now, so I make sure I have more than enough bandwidth to talk with you. I spend a lot of my time traveling around, speaking at different conventions and conferences. I'm technically, with double quotes around it, an influencer at some conferences. I'm also the ANDOUC community liaison for our summit event that we have coming up in April. Yes, I am the oldest guy in our martial arts class. The oldest person is actually my wife, and she regularly beats on me in class. So yeah, I'm used to having my bell rung. But I'm also an optimistic futurist. Please note the ears, if you will. Yeah, I gave a conference keynote in 2024 for ANDOC in Redwood Shores. Key thing is, please do, if you want to reach out to me, please email me at Jim the Y Guy. Follow me on Blue Sky. Best place to really connect up with me is probably LinkedIn. Just search for this strange Polish last name, and you should be able to find me there. So, one other point about the ACE program. I have been an Oracle ACE director now for about, I guess I'm starting my 12th year or into my 12th year. This is an organization that, again, I do not work for Oracle. Oracle supports a community of around 600 plus Oracle ACE Associates, Oracle ACE Pros, and Oracle ACE Directors. There's about 75 to 80 ACE Directors at any given time. The difference between us, if we go up that hierarchy, is some of us just do more than others. I tend to do a lot. I speak at least once a week on average during the year, travel to some conferences as well. As I mentioned, I'm off to Vancouver, British Columbia next week to keynote as well. But if you are currently involved with Oracle technology, I had a colleague that was like, oh, I don't know if the ACE program's for me. And he had been doing blog posts and articles and some other presentations, not at huge scale. He submitted his application for Oracle ACE Associate, and he was accepted almost immediately. He had been doing the work. So again, check out the ACE program. Here's all the links that you can see there. Go to ace.oracle.com if you want to find out more. It's a great way to build your network. And with the uncertainty of IT these days, your network is probably going to be your saving grace if anything goes south. Now, let's talk about today's topic. As I mentioned, I love talking about maps, and I love talking about the future. And the future in my mind is electric. here in the United States, I'm based in the Midwest in the city Chicago, which is right smack dab in the middle of the country. We are seeing very interesting things happening, even with the changed administration in our nation's capital. Earlier this year, wind and solar overtook coal as the major source of electricity in the United States. Have a little story about that picture up at the top in just a few more minutes. California, our largest state and the fourth, one of our largest states, but economically, it is the fourth largest economy in the world, has almost 50% more EV chargers than gasoline nozzles. So California is a leader in re-electrification, electric vehicles, solar power, wind power. We're also finding out that EV charging stations, which we're a little slow to develop them here in the Midwest of the country, but we're starting to see that there's positive effects for businesses nearby, right? It takes you 15 to 30 minutes for a full charge of your EV. What are you going to do? You're going to walk over to a local cafe, maybe go shopping at a local store. It's not just about rich people, if you will. Prices of EVs continue to fall. We're starting to see some things here in the US where it's possible we may see an EV for $20,000. So prices are falling dramatically, and it's obvious that this is not going to stop. By the way, that picture up in the top left-hand corner, that is a picture of solar arrays on top of the museum in the state of Kentucky, which is a large coal-producing region, or had been, because that museum with those solar panels is completely powered by those solar panels. It's the Kentucky Museum of Coal Mining. Yeah, let me say that again. The Museum of Coal Mining is powered by solar. This is not going to stop wherever you are in the world. If you look at what China is doing with alternative energy, renewable energy, it's not going to stop. China is poised, if it hasn't already, to become the leader in renewable energy. So it's not an easy fix. It's not an easy slog, as we say here. Consider the US. It's a wide, huge country that spans, 2 oceans. The challenge is solar, wind, and even nuclear power generation. Full disclosure, I'm an investor in a company called NuScale, N-U-Scale. It is working on what are called small modular reactors. You may have heard about NuScale because they just recently signed a deal to create around 600 megawatts of power for some states in the middle of our country. But they're also very interested in supplying energy to data centers. That's another big challenge, right? So solar, wind, nuclear, spread out across the country. However, renewable energy production sites are very unevenly distributed. Our Great Plains, great for wind, excellent for wind. So are our 2 shorelines. But if you're not there, or you're not in a real sunny place, you're not necessarily going to have that kind of access. So what we really need is to build reliable battery storage systems and locate them closest to those resources. And by the way, we're also going to have to think about here in our country about rebuilding our electrical grid. And there's actually quite a bit of movement in that direction right now. So these are all the challenges that we're facing, and we've got to think geospatially about how we would make that happen. So that's my use case. Here's what we're going to talk about today. I'm going to gather a bunch of data sources that have geographic or geospatial components. I'm going to load them into a 23AI database. I'm going to create SDO geometry data type objects as appropriate. And then I'm going to build spatial indexes on top of them for efficient access and processing. Well, so what? What's different? Here's what's different. Everything in that light green box in the bottom. We have the choice of vector tiles or using in concert with vector tiles, H3 spatial indices. And why are these important? Because they're mind-blowingly faster. And I'm going to demonstrate that in just a second. If I implement the vector tiles, I now have the resulting geometries that I can leverage. I'll also use, in step 7 here, REST API modules to serve up vector tiles as blobs to mapping facilities, to mapping technology. And if we have enough time, I will briefly talk about caching vector tiles for improved geospatial query performance. I'm finding that this layout, this map, if you will, or flowchart of what we're trying to achieve really helps anybody listening because you understand where I'm going. And I've started to incorporate this in every single presentation I do when we're talking about code, especially. So let's go talk about vector tiles. But before we do that, let me bring up an application that I've written. This is an application in Apex, and this particular application actually leverages something called a native map region. And I'm just going to go over here to show you what I've got in this map that I'm going to load right now is around 180,000 points in a point cloud, if you will. And what points are these? Well, solar or photovoltaic arrays, solar arrays, wind turbines, and EV charging stations with a different color scheme. Now, this is an Apex app using native map regions. Look at how long it's taking to load the entirety of these data. This is focused centrally on a point near my home here in Illinois. And if you notice, I'm still waiting for something to load on this map. If I'm trying to do strategic or even tactical research into where it would make sense to place the battery storage units appropriately, this is not gonna cut it because it takes a long time to load the data points. We're actually almost there. It should just about be ready to start loading some points. This is, again, Apex technology sitting on top of native map regions. And here we go. The blue are EV chargers. The green are wind turbines. The reds are photovoltaic arrays or solar panel arrays. And if I zoom back from the United States, you can start to see that certain areas of the country have a lot more wind turbines, green, than they do solar panels. And as I zoom around in here and even pull back a little bit farther, notice stuff is still taking time to load. If I'm trying to do stuff at a at a United States or continental level, this response time is horrific. It's not going to work for modern apps that deal with geospatial. So I just want to give you an idea of how fast or how slow in this case it takes to load 180,000 different points using traditional technology. And you know what? This isn't going to cut it. What we're going to have to do is find a better way. So I'm going to close this out completely. And I'm running against an autonomous database, by the way, which is just fine. But what I want to show you next is the alternative, vector tiles. So here we go. If I take a Mercator projection of the world, right? This is why everybody gets confused about how big certain things are. No, Greenland is not half the size of the continent of Africa, right? Mercator projections end up distorting sizes of how big things really are, okay? But imagine, in any case, if I took a Mercator projection, cut it up into evenly sized squares, tiles, if you will, and at the lowest, or scratch that, at the highest level, looking at these squares, imagine only four tiles, because that's the highest level. And if you look at it a different way, right, I could take those tiles and find a point anywhere in the world at a particular zoom level. And if you imagine these tiles here, these blocks, right, ranging from an XY axis here, as simply nothing more than little PNG files, right? That's what I really would like you to think of these. I can, however, leverage a really cool thing about vector tiles. Remember I said at zoom level 0, we have 4 tiles, 1, 2, 3, and 4. If I drill into the tile in the right-hand corner, what I have now are 4 more tiles. And if I drill into any one of those tiles, I have 4 more tiles and more and more, all the way down to zoom level 22. We start with zoom level 0 at the very, very top. At the lowest level, these tiles resolve to just a few meters on each side. So the idea here is I can zoom in to just about any particular level and continue to zoom down lower and lower and lower to identify not just geography, whether it's geospatial, if it's got even a 3-dimensional aspect to it, but where the points are located in which vector tile, where on the grid. Hopefully this makes sense. That's the easiest way to understand vector tiles. The cool thing is with 23AI, I only need to know 2 procedures or functions: get vector tile and get tile envelope. Those are the only 2 I need. Get vector tile will generate what's called a blob, a data type of type blob, that represents what's called a mapbox vector tile, an MVT. There's another function called get tile envelope. We'll see an example of that. If I know the tile address, I can tell you where the tile envelope, where that boundaries of that vector tile are, and at what zoom level. And that's all you need to know. Yeah, right. Check out the documentation here. Click on this link, take a look at it. You'll be getting these slides, by the way. I've already shipped them over to SAOUG, but it's much more complex than this, but it's actually easy to implement. So let's take a look at this. I've got a table called EV charging stations. See that there? It has a geometry column, a type of STO geometry named appropriately geometry. Also, inside that table, I don't just have the geometry column. I've got an address, a city, a state abbreviation, as well as the longitude and latitude of points inside that table, because this is a list of EV charging stations in the United States. Also, if I pass that information into get vector tile, I have to tell it what are the tile X and Y. Remember, we talked about taking the world and cutting it up into smaller and smaller tiles. So at zoom level 9, or about the 10th level down, as we go 0 to 22, go look at tile 129X, 187Y, and show me what's there. And when I run this query, here's what I get back. Well, that's useful. If you notice, it's almost all gobbledygook. There are some things in here you can see. There's something like State ABBR and Johnson Creek and yeah, there's some text in here, but most of this is simply a source of points and polygons and related descriptors. To the human eye, this is useless. But to a mapping application, as I'm going to show you in just a minute, this makes perfect sense. So I can also filter the results of a query of get vector tile with the simple predicate statement. So for example, let's assume that at tile zoom level 9, tile X 129, Y 187 actually had data from more than one state, more than one geopolitical division. I only want to look at stuff in the state of Wisconsin, for example. Okay, fine. I can actually say to Oracle, hey, before you send back this result set, only show stuff for Wisconsin. And of course, I could make state abbreviation a bind variable if I wanted to and pass that back. Finally, one last thing, a quick intro into get tile envelope. What have I got here? Well, when I say show me, select STO util, get tile envelope, what I'm doing is specifying that same tile, zoom level 9, X and Y, you saw the prior example, that's the boundary area. I want you to take a look at data in the existing PV sites table and using the boundary that we just used to establish with get tile envelope, look and see if there's any data for the state of Wisconsin in 4 counties. in the United States, that's our second layer typically down. We have states, then we have counties, then we have municipalities, typically in our division of geopolitical resources. That calculation there with SDO relate, let me take a little bit of a look at this. What's that first number in green? 4007-5016. That is the side of one of the large vector tiles at zoom level 0. So about 4 million, right? Million? Yes, 4 million kilometers on a side is the largest vector tile at zoom level 0. Well, what's this divide by power 2 to the 9th? We're at zoom level 9. So what I need to do to actually calculate the boundaries within that tile, I have to divide 4 million kilometers on a side by 2 to the 9th, and then multiply by 1/1000 to go down to meters size. That's probably more than you thought you would need to know and more than enough math for a Thursday evening. But that's what that calculation actually means. What this is really saying is, see if there's any points that are within this envelope and only show me those points. That's what this actually does. So let me show you how that actually works. I'm going to go back over to my other example. So let me come back over here for a second. I'm now in the, what do we call this puppy? This is my VS Code editor. And what I've got here, remember we were talking about those EV chargers? I've got a function inside here. This is just an HTML file that says, create a map layer called EV chargers layer. Where is it going to get its data from? Something called EV chargers. And what it's going to do is actually call a function. It's a little bit higher up here. Sorry about that. And it's going to call a function and pass in a zoom level, an X, and a Y to it so that it can return what's called a trying to remember the name of what the P stands for, a buffer file, a proto buffer file. That's what it is. And what we're basically saying is, I'd like to open a map inside HTML, and I'd like to display a bunch of map points. So I'm running this with live server. I'm going to open this map up with live server. It's actually a function of what's called MapGL, a Mapbox.gl, excuse me. And did you notice how quick this map loaded? This is not that far away from where I actually live, by the way. I live right around here. Here I am in a map of the United States. I'm taking a look at the wonderful state of Wisconsin, and I'm zooming back a bit. This is a list of, or a display of, the green are wind turbines. The reds are photovoltaic cells. The blues, light blue center, dark or darker blue, or I'm sorry, light blue center, darker blue outlines are EV charging stations. That same other map that I showed you in Apex is here now. And if you notice, as I zoom in, we zoom in really fast, okay? And I can even come over here, since I know these are wind turbines, I can right click on one of them or mouse click on one of them, and it will tell me that, oh, it's in the state of Wisconsin, zip code 55027. The height of that particular wind turbine is 118.6 meters, and its capacity in kilowatt hours is 1,500. I can also look at other things here. Let me zoom back a little bit and find a couple of charging stations. Let's take a look at this charging station right here. This charging, whoop, I may have to get right on top of it. Let's try getting right on top of one of them. Here we go. This is a charging station at a particular destination, and it has 6 level 2 chargers. So how did you do this? It's all Oracle. Let me show you. What I did is I built an ORDS, Oracle REST Data Services, REST API module, defined a template within that module called EV chargers. And here's the magic. This particular module has a handler, and this handler outputs an ords.sourceType media output. Remember I showed you that example of that gobbledygook blog? That's what this key source type definition actually means. What am I outputting? Select a vector tile as the media type. Look at the EV charging stations table, the geometry column, and by the way, tack on to the output of that vector tile the address, city, state, abbreviation, the EV levels. Remember I had in my little mouse over EV level 1, 2, and 3, right? EV level 1 is the lowest level. It's basically 120 volt household current. EV level 3 is Tesla supercharger level. And of course, the latitude and the longitude. And there's that X, Y, and Z. Yeah. You see how this all glues together? So when I define this handler, then I'm able to display vector tiles in multiple layers. And remember, I just showed you I had vector tiles that had wind turbines, EV chargers, and also photovoltaics, right? PVA arrays. We didn't actually look at those, the PVAs, but they are there on the map. And as I drill deeper in and deeper in, I can see more detail. And it displays uber quickly with vector tiles. And I actually showed you this, right? That if I right or mouse clicked on the different points, I can actually, if I coded for it, bring up other ancillary information related to that point. By the way, the code that actually does that right mouse button is right here. I'm basically saying on a pop-up event, based on the latitude and longitude, I would like you to look at that latitude and longitude at what is at that point and pop up the address, the city, the state abbreviation, and the different EV levels. And just display that as a pop-up on the map. So again, this is using technology called MapGL. And it actually uses a set of functions called MapLibre. If you use Oracle Spatial Studio, you can do exactly the same thing without any coding. But underneath the covers, it's the same. That's basically how this works. I like using this because I don't have to go into Spatial Studio, log in, do all this other stuff. I can just turn on VS Live Server and boom, test if my code and everything else is working. And then if I want to, I can transfer that knowledge over into Oracle Spatial Studio. So that's why I do it this way. I've done it in Spatial Studio, but I don't need to do it in Spatial Studio if I don't want to, right? If I want to just serve these up. So that's basically vector tiles. We've got about another 20 minutes to go. I want to take you into yet another amazing 23 AI feature called hexagonal hierarchical spatial indexing. Why they're calling it H3 if there's only 2 H's, I don't know. I didn't design it, so don't shoot the messenger. But this is some really cool stuff. This is not the same as vector tiles, but the output of what we can do with H3 spatial indexing becomes a vector tile. Because remember, vector tile is just the technology that we're using to display things. So back in November 18, a bunch of guys at Uber came up with a new geographic indexing system using 122 different polygons, 110 hexagons, 12 pentagons. Well, why can't they use just hexagons? Because the surface of the Earth is not perfect. The Earth is not a perfect globe, a perfect sphere. So pentagons had to be used for a couple of places. And you can see one of them right there. There's a pentagon, but everything else pretty much is a hexagon, right? And what they did is quite brilliant. It's sort of like vector timeline, except they said, we're going to take these hexagons, and within each set of hexagons, there's going to be 7, 1, 2, 3, 4, 5, 6, 7 hexagons. They're aligned edge to edge. And as I drill into each one of them, guess what? Another 7 hexagons. At the lowest resolution level, they cover a space of just about 1 square meter. Why did they do this? So that your Uber driver always finds you, is what it comes down to. Now, if you want to read more, actually, it's quite fascinating. I got the links here, and at the end of this presentation, I'll show you the links again. What's different about H3? Well, here's the thing. Each one of those hexagons has a distinct H3 key. So take that very dark orange hexagon right there at the bottom, the smallest one there. It knows that its brother inside its parent hexagon is its brother because they're next to each other in the hierarchy. And it also knows that kind of darker blue one there is its parent. And then its grandparent is that lighter blue outer hexagon. So we've got this hierarchy of hexagons. Maybe that's why it's called hierarchical hexagon. I don't know, something like that. Maybe the hexagons are in there somewhere, but remember, there's other polygons as well, right? Also pentagons. So maybe that's where the missing H is. I don't know, really. So how do we leverage this? Well, unlike vector tiles, we have other functions to deal with. And I'm not going to go through every single one of these and read them to you. That would insult your intelligence, right? But I know, given a given geodetic point, what its H3 key is. I also know what its parent is and what member it belongs to. Now, what is the whole point of H3? It's really aggregation. And we're going to get to that in just a minute. I can create a table called a summary table and then return rows from that summary table and get a vector tile from that summary table. And again, remember, aggregation, not necessarily individual points. Here, what we're trying to do is figure out not where is the wind turbine, but where are the greatest concentration of wind turbines or photovoltaic arrays, or even electric vehicle chargers. And they're all going to be displayed as a series of pentagons. So here's an example of building or using these H3 keys and the hierarchical indexing strategy with H3. I've got 2 different sources here. If you take a look, I've got existing PV sites and existing wind turbines. Totally different tables. However, because I know their latitude and longitude, how do I know that? From the geometry data type, the STO geometry data type in each one of these cases. I can say, hey, if these 2 H3 keys are identical, then link them together based on that H3 key, because no matter what, points will lay within the same H3 polygon, either hexagon or pentagon, depending. I can join data sets together based on that. And then if you look at the first part of this query, notice what I'm doing. I'm counting. I'm summing. I could even take averages, minimums, maximums. Why would I want to do that? Because again, H3 is based on or pointed at aggregation. Where are the most? Where are the fewest? That's what we're focused on. And here's what actually comes out. So the H3 keys, remember, they're built in a hierarchical structure. Not only can I aggregate at the lowest level, but I can take these totals and aggregate up into higher and higher concentrations of area, or if you will, higher and higher or lower and lower resolutions. So what does that mean? Well, let's build an H3 summary table. So I'm going to build one called H3 sum wind turbines based on the data in the existing wind turbines table. The geometric column spec is the column name geometry. But I'm also saying count each point as one. Semicolon, turbine capacity minimum. I want you to create another column in the result set that calculates the minimum, maximum, and average turbine capacity for all the sets of wind turbines, key point, within that H3 level of resolution. By the way, notice that I can say, look, if you go below resolution level 7, don't even bother summarizing. I don't care that I going any lower than that. I'm zooming in way too close for that. Don't waste your time. I could go all the way down to level 23 if I wanted to, but I don't necessarily need to do that. And so what I'll get back are counts plus minimum, maximum, and average factors coming out of the total universe of these H3 indexed vector tiles. And here's what it basically looks like. Now, I'm going to jump over to my session here and show you inside VS Code how I implemented this. We're still doing okay on time. Good. So a little different. This is the H3 sum vector tiles, but guess what? I'm still going to use, if you can see it here, I'm doing a wind turbine summary call to, I should say, an ORDS module called WT underscore summary. And what am I passing in? Same thing, Z, X, Y. And what I've done here is for each layer, for the map layer, I've said, hey, depending on what you're looking at here, and again, this is a little esoteric, if the total number of values that are returned are from 0 to 9, then I want you to code them with a particular color. 10 to 15, 10 to 14, a different color. By the way, when you see this, it'll be very obvious that I'm going from a light green to a dark red in terms of the concentration of values within this, right, that we're going to actually be looking at. So let me run this guy. Let me open him with live server. And same geographic area, except now as I zoom back out, notice that as I'm zooming back out, the sizes of the H3 hexagons change as I come back at the different levels. I'm now at the 50-kilometer level. I'm now at the 100-kilometer level. What you're really seeing here is not what points are here, what values do they have, but a concentration, right? A darker red through yellow, through purple, all the way to green. Darker red means more stuff, more wind turbines, as compared to what? To all others in the set. And so if I zoom all the way back out, this is where, check this out. This is really cool. I said all in the United States, right? Well, guess what? We actually, I found this to my excitement, that we even map stuff that's not in the continental United States. There's even a few here in Hawaii, and I think it's the United States Commonwealth of the Marianas, right? But you can see as I zoomed back out, I'm at that lowest level, right? Or at the, if you will, the highest resolution, right? There's even some stuff in Puerto Rico down here, obviously in Hawaii, Alaska. And as we zoom in, we can start to see where most of the wind turbines are. And as I said, they're concentrated mainly in the center of the country. But there's a bunch of stuff out here too. And I think we even had a couple that were offshore as we zoom in here as well. So again, H3 is about concentrations, right? And again, do you have to color code these? Not necessarily, right? You could do some other types of things. if you want to emphasize which ones have more than others. But that's just an example of what you can do with H3. We have just a couple minutes left, and I want to give you some time if you do have any questions. It's also possible to cache vector tiles. And remember, the output of H3 is still a vector tile. It's just hexagonal instead of a collection of points, right? A point cloud. So why would I cache vector tiles? Well, let's think about this. Maybe wind turbines is not perhaps the best example, but what I could do is, let's say that I own a series of retail outlets, right? Or think of you're a postal delivery service, right? Where are those particular sites, right? U.S. Postal Service mailboxes, perhaps, or I mentioned a retail store, right? Where are your Starbucks? Where are your coffee shops, right? Where are your chocolate shops, whatever they might be? I want to load them and keep them in the database memory so that when people go after them, because it does take some math, right, to calculate these things and save them, I can retain them much like a SQL result cache. But except instead of it being SQL result set, I'm caching vector tiles. So here's how you would enable vector tiling. Notice that I can enable different maximum levels of zoom or of resolution. I have a higher, or I should say, I'm zooming in lower for existing wind turbines than I am for photovoltaic cells, for example. So again, anything below zoom level 15 for photovoltaic cells, I would not cache them. I would only cache them if they were zoom level 15 or above. Once I've done that, I can also see which vector tiles are actually in use and look at which vector tiles have been created and at what zoom level, and which ones have actually been populated. So I'm leaving you these queries here. I'm going through this quickly because I'm not so sure people use this a lot, but be aware that if you wanted to cache particular zoom levels of vector tiles, you can actually do it. I can also purge the vector tile cache if I want. I can disable it completely and say, don't even waste time on wind turbines or maybe photovoltaic cells or whatever. Yeah, I do not want anybody creating vector tile caching on this. There's just not enough data. Do not waste memory on this. I can also, if I have a different schema, say the GeoSwarm schema, right? I could grant it the ability to look at those vector tiles, even though in my case, the vector tile cache is created in the HOL23 schema. And I can also revoke the capability of a schema to actually create vector tiles. So turn it off completely for a particular schema. Just some example code there. So wrapping up, and then I saw there was one or two questions. I'll try to answer those as best I can. What are the advantages of vector tiles? Faster display of disparate points across multiple mapping layers and across different levels of zoom. If you joined a little late, you would have missed my Apex native map region example, but you saw the difference at how quickly I navigated those. And guys, I'm running this demo, right, on a cheap laptop without a GPU accelerator. So again, you can get the idea that, if you don't have super powerful technology on the client side, it could make a huge difference. I talked about H3 indexing, the idea of displaying aggregate data, right? And being able to understand where the highest concentration or potentially lowest concentration of data points are within a system. You can definitely access these through Spatial Studio or Mapbox HTML JavaScript. And talking to my friends over at Oracle, my Apex buddies that are in the Oracle Spatial and Graph team, possibly. It'll be easier to do this in future Oracle Apex releases. Be aware, you could create an iframe in an Oracle Apex app. I haven't had time to actually build that yet. And then share an Oracle Spatial Studio spatial frame inside Apex. But I'm guessing that probably in the next couple of releases in Apex, you won't even have to do that, right? The technology is definitely there. I have a bunch of stuff for you to take a look at in terms of links to hopefully answer your questions. There's some great blog posts by Oracle out here on this. The documentation on H3 indexing and vector tiles is exhaustive. There's actually some pretty gosh darn good examples. And if you can't get to sleep tonight, actually, it's quite fascinating. Take a look at that second to last one, the Uber's hexagonal hierarchical spatial index. Again, why is it called H3? I don't know. There's only two H's in there unless they're taking the H and the second H in hierarchical. But it's actually fascinating how they built this and why they built it the way they did. And with that, I'm going to turn this back over to our coordinator. And are there any questions? I thought I saw that Thandokazi had a question, if I said your name correct.
That's indeed correct. The question is on the chart, Jim. Thank you, Tando, for that question. It goes as follows. What are the challenges to vector tiles and how do we resolve those?
And how, I missed the last part.
The question is about
And
the
how,
challenges to vector tiles and how do they get resolved?
presume by what you mean by how they get resolved. If you're talking about they actually get resolved inside the map. But if we're talking about challenges getting resolved, which I think is what you're asking, I've actually found this quite easy to work with. I haven't seen any particular challenges to putting data together. It's super easy to do. If you take a look at the beginning of my slide presentation, if you're used to working with SDO geometry data types, you will handle this without any challenges, right? I think the most difficult example, I'm just going to go back here, was probably this one that I shared with you. And I've got other example code, by the way, on this. I'm actually working on a second article that I wrote for another publication on the H3 vector tiles. I'm sorry, the H3 indexing aspect of this, but I also did write a nice little article on this. If you want, you can reach out to me and I can maybe send you the link to that if I don't have it in the links there. But the trickiest part is really just trying to wrap your head around the idea of, yeah, there's a series of X, Y tiles, right? Or a tile, a vector tile at a particular location within that XY array. And there's a zoom level aspect, right? So you have to kind of mentally think, if I go back just a couple slides here, that is this probably concept. I had to draw this out to really understand what we're trying to do. We're really drilling down through that pyramid. If you think of that pyramid there on the left-hand side as a series of tiles, and as we go lower and lower, the tiles are getting smaller and smaller and smaller as we approach the base of the pyramid. That's once you wrap your head around that, this actually becomes quite simple. I hope that answered the question, Thandokazi. I got a thumbs up. That's always a good sign. Anything else? Any other questions, guys? I know I went kind of late.
Thank you, Jim. Just two from my end. This is rather complex for me. I'm not sure about others, but I think what will aid, assist with me getting the pieces together will be clarification on the issue of data sources. Data sources, are we just referring to the coordinates or the actual images, or is it both?
Well, excellent question, by the way. For vector tiles, right, you're going to need a latitude and a longitude pair. Bottom line, you've got to have that, right?
Okay.
So The data sources that I used, believe it or not, were all public data sources from the United States Geographic Service. And all of them had a latitude and longitude component. And if you got a lat long, those are easily transformable into an STO geometry data type. So as long as you've got latitude and longitude, you've got everything you need. Okay. And then, of course, any other ancillary information, like all that stuff I showed you where I clicked or moused over and then just clicked on it, and that stuff popped up, that all came from ancillary information in the data source. I did have to scrub some of the data sources a bit to, get things down to the appropriate level. But as long as you've got a latitude and a longitude, that's really all that you need for the point cloud, if you will, of the data sources. So latitude and longitude is really all you need. And of course, some kind of identifier for what's there, right?
Okay.
But again, I took my 3 different data sources, one for photovoltaic cells, one for wind turbines, and one for existing EV charging stations, put them into 3 different tables, and then built a separate module, an ORDS module for each one of those tables. I hope that makes sense.
Which then makes me wonder, right? Especially the last concept pertaining to caching. How do we then get the data refreshed, if I may, especially the locations for the charging stations, having implemented or opted for caching? Do we how do we deal with that?
So if right, I understand what you're saying, right? Because locations change over time, right? Or new locations get added, other locations get deleted. That's really going to depend on your application, I would guess, right? But generally, when we're talking about points on the surface of the Earth, for most business cases, do we really add new things that dramatically over time? Do things really change that dramatically? Probably not. It's not quite the same as like a transactional banking system, right? So, yeah, you would basically just have to update the data or refresh the data inside the base tables. But once you did that, right, the mapping still works the same. You don't really need to do anything else beyond simple, CRUD, insert, update, delete of the underlying data and make sure that it's populated properly. So, yeah, I guess if you think about it, if I look in another 2 months, I might find 100 new electric vehicle chargers across the Midwest, but they're not going to be added every second. So, yeah, I see your point too. If you're trying to track things that change dramatically over time, yeah, it would really depend on the nature of the application, I would assume, right? Okay. But I think we're here, the way I think about this is that this is more aimed at visualizing stuff that's relatively static, not perfectly static, but relatively static over time, right? So more for, especially with H3 indexing, it's really more about aggregates, right? So new data coming in wouldn't necessarily tip the balance for an H3 indexed vector tile, right? Just the way I'm thinking about it. I think I understood your question properly.
Thank you. As a parting shot, on a lighter note, I was going to ask what the other H stands for, but I think you've already given us the disclaimer on that.
I got no idea. I honestly don't know. I do not know. I looked up in the docs. I have not been able to find it. I'm just like, if anybody finds out, let me know. Maybe it's the second H in hierarchy. I don't know. Maybe it's the guy that wrote it. I'm not sure. But yeah, I'm not sure why.
But thank you, Jim. We still have Anton and Tandogasi on the line. We do appreciate your time. Thank you for coming through. We appreciate your presentations there. For those colleagues, partners, and the friends of the SAOUG who will be coming through later on to access this video, we just like to point out that we are actually less than 60 days away from the conference. We'd like to have everyone registered, preferably before the end of September. It will be a great opportunity for us to get together and share in all things technology and Oracle related. Just as a pointer, this is what I have before us, where you would be able to register your details. Tando and Anton, we are also relying on you to please pass on the message for us. You can come through on both days. Yeah, and the website is as we have it projected. And if there are any questions, you can please come through on our website. We are also available on WhatsApp and directly through chair at saug.co.za. Again, Jim, thank you very much for your time. We appreciate your partnership and
very
looking forward to many more of these encounters and sessions. Tando again,
Thanks very
and
much.
Anton, Debs, thank you all for coming through.
See you all.
Thank
Be
you.
safe.
Take care, sir.